Great. Well, thanks everyone for coming. We're obviously talking about security here. This is probably the only tech talk in 2026 that's not about AI. So let's see. First off, I'm Mike. I'm VP of Technology here. I've been working in PHP for a long time. I wrote a very embarrassing custom framework for a sports blog like 15 years ago. And from there, I've touched Drupal, CodeIgniter, Cake PHP, Symfony, the Laravel, the works. So, as you probably inferred from the title, today we're talking about supply chain security. This has been a topic that's been in the news a lot lately. Even in the last 24 hours, it was Red Hat, I think, that got compromised yesterday. A supply chain attack is when upstream dependency or package is compromised. And before we go into the anatomy of these attacks, I want to talk about some basics of package management first. So we all know this, packages are defined in a manifest. We have composer, we have npm, pip, whatever it is. Versions are locked in a lock file and validated using integrity checks against known correct checksums. And when a package is updated, the package manager looks for new versions that satisfy the manifest. This is a very bare bones manifest of a composer.json, do not steal. And these are 4 different ways of identifying which versions to download. So we have first, branch, obviously just a get reference, points to a commit. We have a commit, which, spoiler alert, is the most secure of the 4. This is an actual hash of the content that you are downloading. We have a tag, again, just another get reference. And then we have a version constraint. So these last 2 look similar. A tag doesn't have any special characters. It's just a specific get tag that it's always going to pull in that commit hash. But that commit hash or that tag can point to different commit hashes, and we'll go over that. And then a constraint. This is pre-approving versions that haven't been published, haven't been written. They don't exist yet. We are just giving them carte blanche to be downloaded and run on our system. So this is the most dangerous one by far of the 4. Preferably, we're all going to use commits, but we also know that they are not as easy to use as tags. And then there are post-install commands, post-install hooks, whatever the package manager is, but this is where this is where Shai-Hulud came in. So the new aspect of that worm was that it would write a commit to the repository that would create a post-install commit or a post-install command and run another command and kind of perpetually commit and try and spread itself into the infected repositories. So this is the special sauce, which is why we're talking about this today. There's an XKCD for everything. So as we've all learned, all digital infrastructure is basically held up by a single person somewhere in Nebraska who's been maintaining it since 2003. And while this is funny, the one thing that I've been thinking about differently lately is that square is not a package, it's a person. It's trust in that person. We are trusting that the person who's deploying that is who they say they are, and it's just not always the case. There's multiple maintainers on a single package, they move around, and we don't know that. So that is kind of the crux of the issue here. So how do they get compromised? What's the mechanics? It's really just 2 steps. First, there's identity assumption. By some mechanic, the attackers, either through social engineering, through stealing credentials, through whatever it is, they are assuming the identity of the maintainer, and then they are shipping the payload, which is either publishing a new malicious version or rewriting an existing version in place. I mentioned tags and branches. Those are get references, which mean that they are pointing to a commit. They are not immutable by themselves. Shai-Hulud, so last September, I believe, September, November, came along last year and really made the news. I forget how many eventually were impacted, but I think in the first week it was between 60 and 100 repositories were infected, and then it grew since then. It's the most recent and widespread attack, but it's not the only method for compromising packages. Since then, there have been many mini Shai-Hulud attacks, including the Laravel Lang one from last week, I think, was a mini Shai-Hulud. And like I mentioned before, this attack self-propagates by committing those malicious scripts and then just publishing them. So it gets the credentials from a victim's computer and basically checks the repositories and says, do I have the access to publish a package? And when it does, it just goes wild and publishes everything it can. So this is what I was talking about before with the retagging. So in a typical Git history, we have a release or a tag and it points to a specific commit. So we have 3 commits here. But a attacker can create a new tag and then force push the tag to point to that new commit. So if you have a log file, which I hope that you all have log files in your repositories, you will not pull down the new code, but if you were to run update on that package, it will try and fetch the new content and you will be susceptible to this attack. So NPM is very much no stranger to supply chain attacks. They've been happening for a while. Shai-Hulud was the scariest, but it's not the first, and it's definitely not the last. Event stream, almost 6 million downloads a week, compromised, social engineering. UA parser, almost 30 million. Account was hijacked. Axios, same thing, 113 million downloads a week. That was account hijacked. And then yesterday, Red Hat Cloud Services, there was 32 packages compromised, and that was a mini Shai-Hulud. So this is something that NPM has been dealing with and trying to fix for a long time. And I think that some of the remediation that I'm going to discuss that Composer did in Packagist, they probably worked with NPM to kind of coordinate on strategy. PHP is starting to see this. There are, of course, other compromises, but they haven't been as prevalent as covered. But we're starting to see that happen more and more. So Intercom PHP was compromised in April. That was mini Shai-Hulud. Laravel Lang was compromised last month. That was a Git retag. But thankfully, Packagist and Composer were aware of this. They saw it happening in NPM and other repositories, and they were working behind the scenes to remediate this and to fix this before it became a huge issue. And hopefully it is going to work. We'll find out. So they've been preparing for it with immutable releases. So this is all live right now, and you can enable this if you are a package maintainer. So you can enable immutable releases so you cannot override tags once they are pushed. Composer 2.10, which was released again, I think last week, they have added a lot of new policies. So malware policies, advisory policies, abandonment checks. And these are all powered by, I'm going to forget the security company, but they're in partnership with one of the large security companies for this automatic scanning. The transparency log. This was used in the Laravel Lang compromise to very quickly figure out what the issue was. Basically, every tag change is now recorded and publicly available. So how do you defend yourself? It all depends on what hat you're wearing. So you could keep all packages in your version control and manually update for upstream changes. But in that situation, you'd be wearing this hat. You could fork every dependency and point your manifest at your self-hosted forks and pull upstream changes manually after review, which I've talked to friends and they're doing this and they are insane. They get a tinfoil hat. What's real is the two hats are consumer and package maintainer. You can't stop someone compromising a maintainer's account. You cannot fix the guy in Nebraska who just doesn't care about that package he wrote 15 years ago. So you defend the only thing you can control, which is what code reaches you and when. And as a package maintainer, you are the target. You are the account that they want to compromise. So you have to guard your identity and your history. You have to make sure that a stolen account can't rewrite what you've already released. So as a consumer, you could pin your versions to commit hashes, which again is not necessarily the most convenient thing, or immutable tags. You can check to see if that's, I'm not sure if it's enabled by default in NPM and packages, but verify that you are using immutable tags before putting in your manifest. You can avoid using version constraints. Please, for the love of God, avoid using version constraints. That is the number one way to get hacked, particularly if you're somebody who just YOLOs it and does composer package update. And be intentional about updating dependencies. This means, if you are managing software that is used by a lot of people, go through each package, read the change log, look at the changes. It takes some more time, but you're going to be more secure and hopefully identify when. Literally, I think the Shai-Hulud, the workflow that was deployed and committed without the people's knowledge was called like Shai-Hulud.yaml or something. It was very evident what it was. As a package maintainer, enable MFA now, tonight. This is not a silver bullet, but it is the immediate and most impactful thing you can do to avoid being hacked and avoid your identity being compromised. You can use trusted publishing with OIDC authentication instead of long-lived tokens. This is available in both NPM and packages. I checked. If you're not familiar with OIDC authentication, it basically is a short-lived token. I think max I've seen is like 6 hours, and it's authenticating directly with a provider like Amazon or Vault or some secrets provider. Do not use shared publishing accounts. A lot of companies will have, Red Hat Publishing as their account. Sorry to speak over the dead. But they usually have more than one person who has the credentials to that, which it just opens the attack surface by so much. Individual attributable accounts enable way more effective containment and tracing. And then don't rewrite history. Enable immutable tags and releases if that is not already enabled by default in your package repository. Publish a software bill of materials and provenance and attestation. If you're not familiar, this is basically a reference of all the software, all the packages that are used within your service. It is a pain in the ass, but a lot of services automatically generate it now based off your manifest. This does not increase security, but it makes it way easier to trace issues and figure out what the source of a compromise came from. And then add security scanning. Aikido, that was the one. Aikido is the one that's partnering with Packages. These companies, Sneak, Aikido, they do automated scanning, and for the most part, they're up to date with the latest CVEs, and will make sure that you don't publish a known, will automatically publish a known vulnerability. That's it. Now we can do questions or share war stories.
Yeah. Question.
Before we dive into the questions, fantastic presentation. That was really good. I was curious, did you make this in Google Slides?
No.
I was like, the animations are incredible.
I feel like you should do a demo on how we did this slide deck.
Here it
How
is.
did you do that slide deck?
This is slide dev. This is the entirety of the slides, is a markdown file.
All right, well, I think we should revisit on our presentation capabilities.
I've already talked to Kate about it.
That's awesome. My question was going to be, what's your take on Dependabot as like a mechanism for keeping things up to date without using sort of more permissive version constraints?
I am a fan of Dependabot. It's basically the glue, right, between other security tools and the user. So, and it's basically for free. I think that GitHub runs it for free. It runs on Actions, but you don't like enable it. Whatever free tool your version control or package repository offers, it can't hurt. Enable it. I think that Dependabot has some blind spots in certain ecosystems. A lot of my friends, like the ones who are talking about forking every dependency, they're working in robotics and they're working in Terraform and Kubernetes and a lot more close to the metal things. So like that makes more sense. And Dependabot is not very strong in those ecosystems. But we're here about PHP, NPM, very widely used, very good. Yeah, turn it on.
Do you think, because I know that they recently, or I don't know how recent it is, but now there's built-in cooldown periods for Dependabot, right? So I think we recently set ours to 14 days, right? So never see PR an update unless that package has been out for at least 14 days, in addition to the other checks, right?
Okay.
Do you think do you have any sense of what sort of, based on the historical attack size, what like a reasonable window is to wait before you would call? Obviously we're still reviewing the packages, like the PR and the change to the package after that PR is open, but like we don't want to be reviewing a bunch of PRs that will ultimately close, right? So like, do you have any sense of what that window might make sense to be?
I don't. I think that it's a question of technical feasibility as well as your company's appetite for being behind a certain amount.
Sure.
I think that with a lot of these security tools now being implemented at the repository level, at packages, at NPM, that window is closing. I think that a majority of what I've seen is, these attacks are being identified within a couple days, not weeks, not months. They're trying to shoot their shot. Basically, they're trying to get out and get as many spread out as far as they can, as fast as they can.
Yeah.
So, if 14 days works for your organization, then I think you'll be safer for that. But you could probably reduce it down to a week or whatever makes sense. Cool.
Quick question.
Sure.
So you were talking about enabling mutable tags as a package publisher.
Mm-hmm.
Is that something is there an appetite for that to be the default? Like, why should an author have to opt into that, right?
Yeah. So they might be the default in packages in NPM.
Yeah.
They are not in GitHub. And GitHub has a pretty large package ecosystem. If you're not familiar, they have, you can host NPM, you can host PHP packages, you can host Ruby, Docker images even if you want. And a lot of people like, again, for convenience, if you push, version 2.1.2 of your application, they want to tag 2.1.2, but they also want to update 2.1, and they want to update version 2 as well, so that when you're saying I want version 2, you're getting the latest version. GitHub Actions are notorious for that. They're going to basically rewrite every tag on every deploy. So, GitHub has their own reasons for not making it default, but you can go in and switch that in your repository.
Yeah, I was thinking more packages, NPM. Makes
Yeah.
sense. Yeah, interesting.
Yep. Probably better to use packages than a random GitHub, unless it's an internal one, of course. But
Actually, I have another question. I know that, I don't know if it's I'm blanking out on the acronym that you used, and I can't remember if this is it, but the process by which you essentially establish a relationship between GitHub and the package provider.
OIDC?
OIDC, right? So in that scenario, you're essentially prohibiting anyone but GitHub from publishing a package. Like, you can't publish a package from your machine, right? Is one of the
Yes.
one of those constraints.
Yep.
And I just wonder, with I know that one of the TanStack exploit, whatever that was essentially like a GitHub action cache poisoning attack, where the fact that it was the packages were automatically being published through GitHub Actions was actually part of the exploit. And so I hear a bunch of people talking about enabling this on packages, and I'm just wondering, is that now you're just sort of making the single point of attack at the third party that you don't have any control over? And I haven't heard anyone really talk about that side of it.
About the OIDC being a single point of failure?
Yeah, it's like a new point of failure, and it's a point of failure that's like, especially in this moment of GitHub reliability and, the recent issue that we had with merge queues, right? Just like deciding to merge things without passing all the checks. It's like, do you really want to make that system the only place that packages can be deployed from? You know what I mean? Like, is it almost safer to say, no, I'm going to do it on my machine, I'm going to have to 2FA in, that almost feels safer to me. But I realize that everyone on the planet is saying do it the other way, so maybe I'm just wrong. I don't know.
It's all about who you trust, right? GitHub has lost a little bit of trust lately. They've had some downsides. OIDC is going to be in, you can configure that in Amazon, in GitHub, I'm sure in GitLab, Bitbucket, Codeberg. If you want to get really fancy with it or really secure, you could configure OIDC from Amazon and have an EC2 instance and push from there. That's a little clunky, but the mechanics are there. Yeah. The thing that it's trying to solve is that the authentication token is rotated. It might even be after the session is done. So if there were a man in the middle, or if there were something that somehow got the token that you're using to push, by the time they use it, it's no longer valid, and whatever. But it is valid to question GitHub as of late. What's their, are they down to 98 yet percent of uptime? Their uptime has been like just going down, down, down.
I mean, I get it. It's a lot of code going into that.
Yeah.
That system. Anybody else? This was wonderful and terrifying. Thank you.